figured out that to rethink this, how do we go forward? So with Joefish, that's his nickname. I don't know how to pronounce his surname. I'm sorry. With Joe, we started this project called Hercules CI back then. The idea was to rewrite, basically, to keep the SQL schema, to keep everything except rewriting all the Perl and the front end with a proper HTTP API. And I created, back then, an Elm application with a new front end. We did this in free time. And every time we had some free time after work or whatever, we came back and we did some work. After fixing Hydra, we went back to re-implementing Hydra. And then it kind of died off for multiple reasons. One is that it was a big project to do. Second one, we kind of needed to reverse engineer Hydra, and we didn't really anticipate that that's not non-trivial. So we tried to save time on re-implementing the goal schema and asking some hard questions, but we've wasted time reverse engineering. And also it was done in free time again. So I started to ask myself, okay, how do we build something sustainable? How do we build something that will not die again? And what have we failed at this time? So yeah, this took about a year, or maybe less than a year, to come to a state where it still wasn't working. Back then, I was employed at IOHK, and I didn't have any time. And then in April 2018, this year, I left IOHK, and I said, okay, how do we fix this? And looking around at different communities, I found that the only way to do it is to make it a product so that development can be sustained and that people can be assured that after some time it's still going to be there and they can use it and it gets better and better. I thought, okay, it's just me, right? So what can I do? I know that building a CI at this point is hard and it's a lot of work, even though it's like packaging, right? How hard can it be? So this is just on a different level. So I said, okay, I drew the whole CI design, and I said, okay, what's the most minimal thing we can do here? And I said, okay, we can already have a binary cache as a service where you can register, you get a binary cache, and you use it with your own CI, your own development, whatever you want, right? That's the idea. So my first goal was, that setting up a binary cache shouldn't take more than a minute, and you're good to go, right? Whatever CI you use, you plug it in, and you start pushing binaries, and your developers, whoever, can go from there and use those binaries. Now step 2 is what's happening right now, implementing garbage collection, implementing different permissions, multiple read keys, multiple write keys, and so on. And that should be all easy, right? And then step 3 is finally document how to use caches. What are the common things that people get into trouble when starting to use Nix and so on? So we come back to solving the first of the 2 points that I think are important. So a bit of numbers. It's running for almost 150 days. It has more than 500 users registered. It's using 1.3 terabytes of storage. About half of users creates the binary cache, and so far we had 2 hours of downtime, which turned out to be that some Haskell optimization actually in the compiler got the machine down. It used all the memory, so this is still something we want to pursue and fix. But now, at least, if that happens again, it should recover itself. So hopefully that's fixed. So yeah, what I've been working in the last couple of months is a private binary cache. So for people who don't want to publish their packages publicly, and this is going to be a paid feature. And I'm going to try to show that. I have a live demo and a slide demo, so let's see which one works better. how am I doing on time? A few more minutes and then. All right, so now you'll be able to pick if you want your binary cache to be public or private. The UI is not great. This is just a way to show that it works for now. So you pick your cachex subdomain, and then you pick what is the team in your organization that will have access, read access to the binary cache, right? The write access is the signing key, and I will also add support for multiple signing keys. So if you want to have one for the CI and one for developers or whatever, that will be there. So let's create NixCon 2018. And then, yeah, let's say that we want to give, one team on GitHub access, whatever is in there. Well, I'll probably show something like members or something that it's more clear who are you giving access to. And then you create the binary cache. You get instructions how to install Nix, how to install cachex. You get instructions how to authenticate from your machine to the cachex. And then you push the store paths. One thing I want to make sure here, the signing key is actually the secret key that you only get, that is generated in the browser. It's never sent to cachex. And if you don't make a backup, I don't have a backup for you. So you'll have to create a new cache. I'll make sure this is more clear in the documentation. And yeah, that's basically how you push things with a signing key. And then if you go to the link, this is nixcon2018.cachex.org. Well, this is a development server, so it's not actually there. You'll see that it's trusted by this GitHub user. That's the public key, and then instructions how to use it. So you can put, inside your organization, you can give link, and again, you install Nix, cachex. You authenticate because you need it's a private binary cache. Then you say cachex use, and that configures your NixConf and your netrc configuration, and you can use the binary cache basically. So the demo went well. Yeah, if you go to cachex.org, there is a forum where you can sign up. Probably this weekend we'll send out a private beta access for people to play with if you think this is cool. And now Robert will talk about the second part of what we're working together, the Hercules CI. So yeah. Meanwhile, sorry, meanwhile he sets up, you can probably ask me a question or two.
Questions? Oh, yeah, over here.
So it's actually already relatively easy to set up a private binary cache with S3 also. So what's the main value add of cachex?
So the main value is that, yes, you can do that. There's going to be features that are going to be on top of that that will make your life easier. So like garbage collection, and you will be able to set up with different single sign-ons who has access to that. And yeah, you can use S3 for that, but it's very limited. On the other hand, behind cachex there is an application server which gives me possibility to do a lot of things like searching through the binary cache. And it's going to be connected to Hercules, so the bootstrap of using cachex is going to be faster, right? So it's yeah, those are the benefits for now.
Cool, thanks.
What's the cost model for cachex?
I didn't publish it yet, and I don't want to say what it's going to be. I'm still thinking about it. Most probably it's going to be storage oriented. Yeah, I'm interested to come up with a way that it's feasible for people, that it's not too limiting. I always don't enjoy when there is like an arbitrary limit and you just can't use the service. Yeah, still deciding on this, but most probably everything looks like it's going to be storage size oriented. But if you have some feedback about this, I'm interested to hear. It's not a, no solution is ideal, unfortunately, or at least I couldn't come up with one.
Maybe last question. My Apple Watch is today going to tell me that I moved enough.
Hey, thanks. When I tried CacheX for the auto updates, to review them, I found out that I need to add my own user into trusted users to use it, although I'm only reading from the cache. Why is that?
Yeah, so in Nix, the binary cache can serve you basically, as Ilko said in his talk, right? When you build a package, the actual result of the package can be arbitrary, right? The signing doesn't assure you that, it doesn't sign the actual contents of a package, right? So if you are, if people would be able to just download things in your Nix store from any user, that's basically they could give you you know, non-secure binary, I mean adversary binary, right? If user guest one downloads can download from any binary cache, then they can just put something in, and then user, you know, guest two uses that package, and it could be something not expected, right? So that's the trust model in Nix wants to make sure that users on one machine cannot affect each other, and that's why it's done this way.
You probably might want to have it in your hand. It's probably going to be too far away.
All right. I guess I'll put it there for the demo.
Yeah.
All right. So this is me. This is what I look like. And yeah, I'm kind of somewhat kind of new to the Nix community still. I'm also a bit active on Stack Overflow, by the way. So if you've asked a question there, maybe you've received an answer from me. I hope it was a good answer. Yeah, so I'll tell a bit about myself, some history. Yeah, my story started in 2016 when I was I had NixOS on my desktop, and yeah, this was me deploying an enterprise Scala application on JBoss. That didn't work very well. But also in 2016, this was me deploying the enterprise Scala application with Nix on CentOS, actually. And yeah, so since then, I started freelancing and doing some research into, like, well, how am I going to prevent these kind of situations, improve things, and obviously Nix was going to be part of that. Yeah, so I did some side projects basically, and yeah, I started experimenting with a Nix CI, and I figured out quite soon that building a CI is not just a side project. It's really takes a lot of effort to build a good one. So last summer, I talked to Domen, and we decided to work together, and we redesigned our CI design, and this is what we came up with. So we have Hercules CI, and it'll read, of course, it'll fetch sources from GitHub, but they won't actually go to our service. Instead, we'll provide you with an open source agent that will fetch the sources, build it, use CacheX to fetch the dependencies, use CacheX to push them back when it's done, and report back to the Hercules CI service for notifications and a dashboard and so on. So yeah, these are like the distinguishing features for Hercules. you will be able to control your own build farm. So if you have some exotic things you need, it should be easy to do so. You can have as many machines as you want. And yeah, we strive to be the best and easiest CI for open source Nix users and for companies. All right. So here we go. This is right. This is our MVP, and yeah. So when you go to the application, you just have to sign in with GitHub. We'll be using our GitHub integration to configure stuff like permissions automatically. So now Hercules knows that I'm there, and we can start configuring. So I'll install Hercules now on Hercules CI itself. We have a monorepo that has the actual code. And now it'll be set up so that Hercules CI can actually only access that single repository. All right. So now we can switch to the Hercules CI account and start configuring the agent. And that's just a little snippet of, in this case, NixOps configuration. We have a NixOps module that helps to set this up. So all we have to do now is write that to agent.nix file. Like this. And deploy the agent. All right. Repository showing up. That's good. So now all we have to do is make a change to trigger a build, and I guess what I'll do instead is just push head to feature whatever. And you'll see it starts evaluating. And now it should be building. It's not finished yet. The actual building is something that's almost done. I mean, as a feature. So it'll be stuck in this state for a while. But yeah, we do have evaluation working. And so these are the attributes that are in our project. And you can see there's actually, we found a problem by using Hercules CI. It's adding value. Yeah, so we have NixOp as a development tool. We're building it in our Nix file. And yeah, we linked it in the way that was suggested in the NixOps documentation, but we're not using NixPath to find Nix packages. That's actually a good measure to make sure that you're building the right thing, to make sure that some developers' environment doesn't affect your project. So yeah, that broke here. Turns out that looks like for documentation, it depends on a path that's discovered through NixPath, and it shouldn't. So that's something we'll have to fix. Yeah, so that concludes the demo. Yeah. So, oh, you've seen this. Right. So obviously we're not done yet, and we have some further plans to make this a really great CI. We want to provide some kind of Nix shell functionality. With Hydra, for example, you cannot do side effecting stuff, at least not in a proper way, and we want to integrate this into Hercules CI, to have like a principled way to perform side effecting stuff as part of your deployment pipeline. Yeah, and we're still looking into ways to integrate with container infrastructure like Docker or Kubernetes. There's a huge design space. We haven't really decided how we want to do this, and we would love to talk to you about this and other ways you are using Nix, so we can provide the best experience. Yeah, there's a private beta. You can sign up for it. We'll be sending out emails very soon to gather some more information, and yeah, if you sign up now, you'll be included, and we love to hear from you. So thank you.
All right, thank you very much, Domen and Robert. And do we have questions from the audience? Yes, we do, and I have to do my running thing again. Dum, 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 dum.
So what's your technological stack? Which language this is written in, and can we deploy it as well? And the sub-question, did you manage to reverse engineer the Hydra Cube runner so others can reuse it for their own CI attempts, for example, like micro CI, and go.
Right, yeah, so our stack is basically Haskell for the backend services. We're using Elm for the front end. Obviously, we're using Nix for packaging and deployment. For now, we're using NixOps on AWS, but we probably want to change that into something a bit more flexible. Yeah, and so our agent software is open source. At least it will be when we start the private beta. We will release the agent software, and yeah, it's open source. So definitely have a look at it. How we invoke Nix.
Next question. Oh.
So it wasn't entirely clear to me what the agent is for. Can you say that again?
All right, so the agent, that's the part that you're running on your own infrastructure, and it's responsible for invoking Nix for evaluation, for invoking, well, basically Nix build, and yeah, it'll fetch dependencies, obviously, and it'll upload those build packages to a binary cache.
Oh, okay. So the evaluation and building is not done by the Hercules CI service.
Yeah. So at least for now, the hard work, so to speak, is all done on customer infrastructure. We may implement a more hosted version of the service in the future, but
Right, because that would be a very compelling feature.
Yes,
to
yes,
just
of course.
provide that whole.
Yeah. So our first approach is to make it really easy to do it on your own infrastructure, and probably in the future we will look into hosting the entire infrastructure, because for most people it's not required to host their own infrastructure, right? Because many applications are running on like commodity hardware. So yeah, for those people, we want, if we can make it even easier by hosting their agents, we will do so, probably. Yeah.
More questions? Nope, doesn't seem so. So yeah, thank you very much again, Domen and Robert, for your talk. And so next up, we've got a 1 hour break for lunchtime. Enjoy.